So we have two different lessons on solving. Our first one is solving exponential equations, and then our next one's going to be solving logarithmic equations. So before we get into it, I just want to do some review. So if you feel like you already understand the first two slides, you don't have to write anything down. Okay, so this is totally review, so I'm going to go pretty quick through it. But just remember, expanding has three different properties. So remember, if it's division over here, you're going to subtract. So it's a log base a of b minus log base a of c. If you have multiplication here, when we're expanding, when it asks to expand, this is condensed, this is expanded. Remember, we can go back and forth. When it's multiplication, we know we add. So log base a of b, log base a of c, and we put a plus sign in between. When we have a power, when we have a logarithm raised to a power over here, remember we can bring it down into the front and make it c times log a of b, and that c goes away, it goes to the front. Those are three different expanding logarithm properties, so that's just a review. These are review as well. So remember here, if we're going to expand, we have to break each of these pieces up. So this is a piece, this is a 5, right? That's separate than x squared, which is separate than y cubed. So there's three different pieces here. To expand, we know it's multiplying, right? All of these are multiplying, so we're going to be adding each of them. So we're going to say log base 3 of 5 plus, because it's multiplication, log base 3 of x squared plus log base 3 of y cubed. Now the only last step that we need to do is this property where it says if you have an exponent, you bring it to the front. So we have two exponents. We have an exponent here and here, so we're just going to bring that to the front here and bring that down to the front here. So the very first term stays the same, and then it's plus 2 log base 3 of x plus 3 log base 3 of y. So this is just review. Again, you don't have to write this if you don't want. Here it's division. So we know if it's division, we're going to be subtracting. Now, this is actually really key. Do you see how there's a 9 and an x and a y to the fourth? A lot of people might say log base 2 of 9x minus this. But these are two separate terms, so it's going to look like this. Log base 2 of 9. These are two separate terms. So log base 2 of 9. And then plus, plus, because this is multiplication up here. So 9x is multiplication, so plus log base 2 of x. And then this is where the division comes in. So now we're going to put our minus log base 2 of y to the fourth. Do we have any exponents we need to bring down? Yes, right here. So we're just going to bring that down to the front and write the first two terms the same. So minus 4 log 2 of y, and that's your final answer. So that's just some examples again of how we expand. Now condensing is the opposite. Remember, condensing is if we started here and we wanted to get back up here, or started here and wanted to get back up here. So when we're condensing, remember that logs must have the same base to condense. So let's just review these rules really quick. It's the opposite. If you have c times this whole log base a of b, this c can go up and it's going to become an exponent. So this is if we're trying to condense. Okay, here, if we're adding, we're really multiplying to condense, so log base a, but remember these have to have the same base. So if this was a 5 and this was a 3, we couldn't combine them, right? We're going to multiply here if they're adding, and if they're subtracting, we just divide those two terms. So remember, that's our condensing. It's just the opposite. So let's review a couple condense problems, and then we're going to get into our actual lesson. So here, they both have the same base, so we can combine these two. The first step, remember, is to start here. We have to start at number 1, where if they have a number in front, we bring it to the exponent. So it's a log base 5 of x cubed. We're going to bring that up, and then we bring this up. Plus log base 5 of 7. So see how this 7 goes up here, and this 3 moves up here. Now the very last step is, okay, well, if it's addition to condense, we're going to multiply x cubed and y to the 7th, and we're going to keep that base the same. So log 5 x cubed times y to the 7th, and that's our final answer. Now here we have a 2, and a 4. That means this guy cannot be included in their party over here. So they have to have the same base. So here they both have 2's, but the first step, remember, is always if there's a number in front to bring it up to the exponent. So we have to bring that up first. This guy we don't have to do anything to, we just drop it down. But this 6 has to go up here. Now it's not a -6. Remember that negative is not attached to that 6. That negative means we divide eventually. Just the number in front goes up here. Okay, and then same thing here. That number 3 is going to be a cubed now. It's going to go up to the exponent. Okay, so we can combine these two, and it's going to be division because it's a subtraction sign. So x over y to the 6th plus log base 4 of z cubed. We cannot combine because one has a base of 2 and one has a base of 4. Okay, here's our lesson. So when we're solving exponential equations, these are the steps we want to take. Now, what does an exponential equation look like? It looks like something like this. Y equals a times b to the x. What do you notice about the exponent? The exponent has an x in it. It doesn't matter if it's x plus h, right? So, oh my gosh, I'm so sorry. That's my dog. Okay, so if it looks something like 5 times 3 to the x, this tells you it's an exponential equation. This also tells you it's an exponential equation. So it doesn't matter what's written up here, but if there's an x in the exponent, it's an exponential equation. Okay, try saying that 5 times fast. So if there's an x in the exponent, it's an exponential equation. Okay, so these are the steps. Take the ln, that's not in. That's why I capitalized it this time around, because a lot of people thought I was putting in, which makes sense. It looked like an I. So this is an L. So when we're solving exponential equations, the first step is to take the ln of both sides. Then we're going to use the logarithm property. So ln of a to the m. So the logarithm property, remember, we just did this. It means to move that m to the front. Whatever this exponent is, we move it to the front. We did the same thing when this said log, right? Like log base 2 or something of a to the m. We'd move that m to the front. We do the same thing with ln, with the natural log. So it looks like that. And then we use algebra skills to solve. Those are the steps we need to take when solving exponential equations. Okay, yeah, I just explained this. So when there's an x in the exponent, that's an exponential equation, where a variable or an x is in the exponent, okay? So examples. Solve. So look at here, there's an x in the exponent, right? You have 3 raised to the x equals 15. Can we figure out what x is? Not just by like an even number. Like, for example, if I had this, you could tell me x was 2, right? Because we know for sure 3 squared equals 9. 3 times 3, which means that this would have to be a squared. 3 squared equals 9. But if you have 3 to the x equals 15, that's going to be some decimal number. So I don't know what that is. So this is how we solve. The first step is to take the ln of both sides, the natural log of both sides. So I'm going to put ln just in front of 3 to the x and ln in front of 15. Okay, so all I did was I didn't change these numbers, I just put ln in front of it. Now what's the next step? Use the logarithm property. So remember, if there's an exponent up here, we have to move it to the front, which there always will be an exponent because it's an exponential equation. So we have to move this to the front. So we're going to say x times, now we have x, which we move to the front, times ln 3 equals ln 15. Now, if you put this in a calculator and you put this in a calculator, those are numbers. So tell me how you'd solve this. If I had x times 3 equals 15, a more common way of seeing it is like this, 3x equals 15, right? How would you solve that? You would divide by 3 to each side to get the x by itself, right? In the same way, we need to get the x alone here. So we're going to divide by ln 3. Divide by ln 3, because we need to get that x alone. So we're going to divide each side by ln 3. This is just some number. Don't let that confuse you. Okay, now x is by itself. We can cancel out the ln 3, and we have x equals ln 15 over ln 3. Now that, if we put this in our calculator, which practice putting this in a calculator, not on the computer, on a calculator that you can use on the quiz, because there will be a quiz next week. So ln 15 over ln 3. Practice putting that in your calculator. You should get this answer. Now, this one is called an exact answer. So if I ask for an exact answer, or if my Open Math asks for an exact answer, this is what you put. The one on the bottom is an approximate answer. Okay, so it just depends on what we're asking for. Okay, notice again, this is an exponential because there's an x in the exponent. What's the first step we did over here? We took the ln of both sides. So I'm just going to put ln right in front of each term. Now what's the next step? We have to use the logarithm property, which means this 2x moves to the front. So 2x times ln 7 equals ln 8. Now we need to get this x by itself. 2 times x times ln of 7. That means I'm going to divide every single piece, like both sides, by 2 by an ln of 7. Because doesn't that cancel out the 2's and that cancels out the ln 7? That means I do it in one step. Okay? So I just have an x left on this side, and then I have ln 8 over 2 ln 7 on the other side. Now this is called an exact answer. If we put it in our calculator, which please practice this is your approximate answer. Okay, number 3. Again, I have an x in the exponent, so I'm going to take the ln of both sides. This means that I can now move this x minus 5 to the front. Now, be careful when you have more than one term. See, we just had an x here, we had a 2x here, which is still multiplication, so this is still one term. Here we have two terms. A term is separated by a plus or minus sign. So we have an x and we have a negative 5, right? So see how I brought the whole thing down, but I put it in parentheses? Please do that. Okay, so you're going to divide each piece by ln 6. So divide by ln 6, divide by ln 6. That means that this cancels out, and we're left with x minus 5 equals ln 18 over ln 6. Now, let's say this was x minus 5 equals 10. What would you do to the 5? You'd add it, right? We're doing the same thing, even though we have natural logs or ln. We're doing the same thing. We're just adding 5. That cancels the 5's, and we're left with x on one side of the equation equals this whole thing, ln 18 over ln 6 plus 5. We can't just add the 5 to an 18 or a 6, right? These are numbers. We can't just combine that to 18 and 6. We just put plus 5 at the end. Okay? Again, you can have an approximate answer if you put this in a calculator and then plus 5, but we're just going to leave it like that. Okay, so 2 more. So again, we have an x in the exponent, so we have to take the ln of both sides. The next step is moving this x plus 2 to the front. Remember, always put it in parentheses, especially when there's more than one term. Okay, now look at this. Do you recognize this? This term ln e means something. Okay, so if you put that in your calculator, in fact, try to put this in your calculator, ln of e. If you put that in your calculator, you're going to get 1. The natural log of e is 1, always. Okay, so in this case, if I brought down my x plus 2 and I multiplied it by 1, and then I just brought down my ln of 5, natural log of 5, isn't anything times 1, like x plus 2 times 1, isn't that just x plus 2? So we just have x plus 2 equals ln 5. Well, how do you get rid of that plus 2? You're going to subtract it from both sides. So that cancels, and we're left with x equals the natural log of 5, or ln 5, minus 2. So if you have ln e and you put that in your calculator, it equals 1. Okay, last one. So now this one, we need to do one extra step before we take the natural log, the ln. Notice on this one and on our other 3 examples, we already had the term by itself. So we had e to the x plus 2. We didn't have anything added onto the front or being added or subtracted to this. We just had this term. So we automatically take the natural log. If we have something like this, we have to do a couple things before we can take the natural log. Let me ask you this. If you had, let's pretend it was an equation that looked like this. I'm just going to write it down here. 8x minus 15 equals 10. What's the first thing you would do? You would add 15, right? That cancels, and then we have 8x equals 25. Then what would you do? Oops. You divide by 8, right? We're going to do the same steps before we take the natural log. So do you see how first we added 15 down here? We're going to add 15 to each side. And you see then we divided by 8, then we're going to divide by 8. Okay? So don't let that e to the x part confuse you. So the first thing we're going to do is add 15 to both sides. And that's 8 times e to the x equals 25. And then we're going to divide by 8. So we have e to the x equals, I'm going to put that in my calculator because I know most of you don't like dealing with fractions. So 25 over 8 is 3.125. You can leave it like that. Okay, now you see how the e is now by itself? Or even if it wasn't an e, even if it was like a 5, even if it looked like this, 3.125. Do you see how like either way, it doesn't matter if there's an e here or if there's a number here, you have it by itself raised to the x. You need to get this by itself raised to the x before you can do anything else. Okay, so that's why we had to add 15 and then divide by 8 first. Okay, so now we're going to take the natural log, the ln of both sides. So we have ln e to the x equals ln times 3, or ln of 3.125. And then remember that x needs to be brought down, so x times ln of e equals ln of 3.125. What's ln of e? That equals 1. So x times 1 equals the natural log of 3.125. Well, x times 1, anything times 1 is just itself. So that's your answer. Oh, and x equals ln of 3.125. Or, remember, this is an exact answer. And this is an approximate answer. So, or you can round. X equals 1.1394. That's what I got when I plugged in the calculator.